Welcome to the DIY Honda Garage channel. DTC P0327 pertains to the knock sensor circuit low voltage issue found in the Honda Civic models from 2016 to 2021. The knock sensor is crucial for engine performance as it detects engine knock or ping, which may cause damage if not addressed. This sensor communicates with the Powertrain Control Module, PCM, to adjust the ignition timing, optimizing fuel efficiency and engine performance. The location of the knock sensor is typically near the engine block, ensuring it effectively monitors vibrations. By detecting abnormal vibrations caused by engine knock, the sensor can help prevent engine damage. If the knock sensor experiences a low voltage condition, it may result in poor engine performance, increased emissions, or even damage to the engine components. The error code P0327 refers to the knock sensor circuit low voltage, indicating an issue with the knock sensor's ability to transmit proper voltage levels to the PCM. The knock sensor itself is the primary component affected by this code. It plays an essential role in detecting vibrations from engine knocking. By monitoring these vibrations, the sensor informs the PCM, which then adjusts ignition timing to prevent engine damage. The knock sensor is usually located on or near the engine block, often positioned to best detect engine vibrations. If the knock sensor fails or experiences a drop in circuit voltage, proper engine performance can be compromised. Recognizing the components and their roles is vital for accurate troubleshooting. A few possible causes exist for the error code P0327. First, a faulty knock sensor itself may cause low voltage output. If the sensor is aging or damaged, it won't function properly, which may trigger the DTC. Additionally, open or shorted wiring within the sensor circuit can contribute to this error. Wiring issues may arise from wear, rodent damage, or previous repairs that didn't ensure continuity. Loose connections at the knock sensor or the PCM might also lead to intermittent low voltage readings, causing the P0327 code to illuminate. Identifying these issues is crucial for effective remediation. Each of these causes should be carefully inspected during troubleshooting to determine the exact problem. Several symptoms may manifest when the DTC P0327 is present. Primarily, drivers may notice reduced engine performance, as the engine management system cannot accurately adjust ignition timing without proper feedback from the knock sensor. This leads to suboptimal fuel efficiency and possible engine overheating. Increased emissions may also occur because the vehicle's engine is not functioning efficiently, failing to burn fuel completely. Additionally, drivers will likely see the check engine light illuminated on the dashboard. If left unaddressed, the ongoing performance issues can lead to more severe engine damage, underscoring the importance of timely diagnosis and repair. In the first troubleshooting step for DTC P0327, begin by turning the vehicle to the on mode without starting the engine. This will allow the diagnostic system to become active and ready for further checks. The next action is to clear the DTC using the Honda Diagnostic System, HDS. This step resets any fault codes in the system, preparing for a fresh assessment of current conditions. After clearing the codes, turn the vehicle off and then back to on mode to allow the system to reevaluate. Finally, check for any pending or confirmed DTCs with the HDS. If DTC P0327 appears again, this indicates the problem persists, and further investigation into the knock sensor circuit is warranted. However, if the code does not reappear, it is likely an intermittent issue related to poor connections or loose terminals. The second step in troubleshooting DTC P0327 requires turning the vehicle to the off mode. Once off, the next step is to disconnect the knock sensor's 2P connector. This action isolates the sensor from the circuit, allowing for precise testing. Subsequently, turn the vehicle back to the on mode once more to ensure the diagnostic system can run checks on the disconnected sensor. Again, use the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs. If DTC P0328 is indicated during this test, this points to a fault with the knock sensor itself, and replacement of the sensor is advised. If P0328 does not appear, this indicates the issue lies elsewhere, and troubleshooting should proceed to the next step. Moving to Step 3 in diagnosing DTC P0327 involves turning the vehicle off again. The next action is to jump the SCS, Service Check Signal line, using the Honda Diagnostic System, HDS, and it is crucial to wait for more than 1 minute during this step. Jumping the SCS line allows for safe disconnection and testing of various circuits without interference from the diagnostics. After a minute, disconnect the PCM connector E, which has 80 pins, to access the relevant circuit paths. The next part of this process is to check for continuity between designated test points on the knock sensor connector. Test point 1 is located at the knock sensor's 2P connector number 1, and test point 2 is at number 2. Establishing continuity between these points verifies whether there is a short in the knock sensor wire to the KSGND knock sensor ground line. If continuity exists, this confirms a short in the wiring, necessitating further repair of the circuit between the PCM and the knock sensor. In the fourth troubleshooting step for DTC P0327, the procedure begins similarly by ensuring the vehicle is in the off mode. Check the continuity again between the same test points, differentiated by the configured test points. Test point 1 now involves the knock sensor's 2P connector number 2, while test point 2 connects to the body ground. This testing method ensures that there are no shorts present in the KS knock sensor wire between the PCM and the knock sensor. If continuity is confirmed, it indicates a short somewhere in that cable segment. A successful and thorough repair should then be made to rectify the wiring. Conversely, if there is no continuity, it implies the KS wire is intact, leading to the need for thorough inspection throughout the circuit, or potentially substituting a known good PCM to see if the issue lies within the module itself. Upon completing the necessary repairs related to DTC P0327, it's crucial to perform a final verification to ensure the issue has been resolved. Begin by reconnecting any previously disconnected components, making sure all connections are secure to prevent intermittent issues from arising. Then, clear the DTC with the Honda Diagnostic System, HDS, to reset the engine management system. After this step, it is essential to conduct a test drive to monitor the car's performance and ensure that no DTCs reappear during normal driving conditions. Record observations and check for increased engine performance or other improvements. If any symptoms related to the original code are absent and the check engine light remains off, successful diagnosis and repair can be confirmed, indicating the issue with the knock sensor circuit has been resolved. To prevent future occurrences of DTC P0327, engaging in regular preventive maintenance is advisable. Begin with routinely inspecting connectors and wiring associated with the knock sensor. Over time, even normal wear can lead to poor connections, which contribute to circuit issues. Additionally, regularly checking engine performance can help identify early signs of issues, allowing for timely intervention before triggering a DTC. Routine maintenance checks should include diagnostics to scan for new codes, ensuring any emergent issues are rectified promptly. This proactive approach demonstrates the importance of regular vehicle upkeep, particularly in monitoring sensor performance and system integrity to promote vehicle longevity and efficiency. In conclusion, DTC P0327 represents a significant issue that can adversely affect engine performance in the Honda Civic models from 2016 to 2021. Understanding the role of the NOx sensor and related circuitry is vital for effective troubleshooting and repair. Identifying potential causes such as faulty sensors, wiring issues, or connection problems facilitates timely repair actions. Symptoms, including reduced performance and increased emissions, underscore the importance of addressing the code promptly. Following the outlined troubleshooting steps ensures a systematic approach to diagnosis, ultimately promoting proper vehicle function. Regular preventive maintenance checks can mitigate issues, ensuring sustained performance and enhancing vehicle longevity, making it vital for drivers to remain attentive to engine health. Please like and subscribe to the channel. See you next time!